Ever wondered how you can learn Arduino in just 15 minutes? Welcome to the world of Arduino, a platform that opens an array of possibilities for tech enthusiasts, budding programmers, and creative minds alike. Arduino is an open-source electronics platform that combines both hardware and software. It's designed to make electronics more accessible to everyone, from novices to seasoned enthusiasts. The magic of Arduino lies in its simplicity. It's a tool for making computers that can sense and control more of the physical world than your desktop computer. It's flexible, easy to use, and most importantly, it's fun. Think about it. With Arduino, you can develop interactive projects, build robots, or even create a weather station. The possibilities are endless, and the only limit is your imagination. But why should you learn Arduino? Well, there's a multitude of reasons. For one, it's an excellent stepping stone into the world of programming and electronics. Arduino simplifies the process of working with microcontrollers, making it an excellent tool for students, hobbyists, artists, and professionals who want to create interactive hardware projects. Moreover, learning Arduino can give you a unique edge. With the rise of the Internet of Things, understanding how to work with microcontrollers is becoming an increasingly valuable skill. Whether you are an artist looking to incorporate tech into your installations, or a programmer wanting to step into hardware, Arduino is a great place to start. Arduino is also incredibly versatile. With a wide range of Arduino boards to choose from, you can select the one that fits your project best. Whether you're working on a small DIY project at home or developing a complex industrial application, there's an Arduino board for that. In the end, Arduino is about making technology accessible, interactive, and most importantly, enjoyable. It's about bringing your ideas to life, learning new skills, and being part of a vibrant, innovative community. Now that you have a glimpse of what Arduino is, it's time to delve into the details. So, what does Arduino hardware look like? At the heart of Arduino is a board, a little like the motherboards you'd find in your computer, but much simpler. This board is the hub where all the magic happens. It's where our input and output devices will connect, and it's also where we'll be supplying power. The board is populated with a variety of input and output pins. These pins are the points at which we can connect various components to our Arduino. They're the conduits through which our Arduino can interact with the world. Some pins are digital, meaning they can only read or write binary signals. That's either on or off, 1 or 0. Others are analog, meaning they can handle a range of values, not just binary. Next comes the power supply. Arduino can be powered either by a USB connection to your computer or by an external power supply. The board is designed to handle a range of voltages, and it also has built-in features to prevent damage from power surges. Now let's talk about the brain of the Arduino, the microcontroller. It's a small, powerful computer that runs your code, reads inputs, and controls outputs. It's like the conductor of an orchestra, coordinating all the different components to create a beautiful symphony of electronic interaction. The type of microcontroller varies depending on the Arduino model, but they all serve the same basic function. Each of these components plays a key role in how Arduino operates. The board provides the physical foundation. The input and output pins allow the Arduino to interact with other devices. The power supply provides the energy required for operation. And the microcontroller orchestrates everything, interpreting the code we write and translating it into action. Now you know the physical aspect of Arduino, let's move on to the software part. Arduino isn't just about hardware, it's also about the software that makes it work. The heart of this software lies in what we call the Arduino IDE, or Integrated Development Environment. It's the platform where you write your codes, compile them, and upload them to your Arduino board. So, how do you get your hands on this software? It's a breeze. Simply head over to the official Arduino website, look for the Software tab, then select Downloads. You'll find versions compatible with various operating systems, be it Windows, Mac, or Linux. Pick the one that matches your system, download and install it. Remember, it's entirely free. Once installed, open the Arduino IDE. You'll find a clean, user-friendly interface. On the top, there's a toolbar with buttons for new, open, save, upload, and so forth. Just below it, there's a space where you write the code. It's called the sketch. The sketch is your playground, where you command your Arduino to do fantastic things. The bottom part of the interface is the console. It displays messages about your code, whether it has errors or if it's ready for upload. It's your guide, constantly communicating about the status of your code. Now let's talk about the role of this software. The Arduino IDE is your control room. It's where you write, verify, and upload your code to the Arduino. It translates your commands into a language that your Arduino understands. It's the bridge between your creative ideas and the physical world. In essence, the Arduino IDE is a powerful tool that makes coding accessible and straightforward. It provides a platform for anyone, regardless of their programming knowledge, to create, experiment, and bring their ideas to life. With the software ready, you are one step closer to creating your first Arduino project. Ready to write your first Arduino program? Fantastic! Let's dive right in. Today, we're going to create a simple program to blink an LED. Let's start by opening the Arduino Integrated Development Environment, or IDE. This is where we'll write and upload our code. Now, every Arduino program has two main parts, the setup and the loop. The setup function is where we set up our program. It runs once when you power on the Arduino or press the reset button. In our case, we're going to set up the LED to be an output. We'll do this by writing void setup, pin mode LE built-in output. Void setup is the setup function. Pin mode is a built-in Arduino function that sets the mode of a pin. LED built-in is a constant that represents the built-in LED, and output is the mode we're setting the LED to. Now let's move on to the loop function. This part of the program runs over and over again, hence the name loop. Here, we're going to turn the LED on and off. We'll do this by writing void loop, digital write LE built-in high, delay 1000, digital write LE built-in low, delay 1000. Void loop is the loop function. Digital write is a function that sets a digital pin to either high or low. High turns the LED on, low turns the LED off, and delay pauses the program for the number of milliseconds specified, in this case 1000 milliseconds or 1 second. So, our complete program looks like this: void setup, pin mode LE built-in output. Void loop, digital write LE built-in high, delay 1000, digital write LE built-in low, delay 1000. Congratulations, you've just written your first Arduino program. This program will make your Arduino's built-in LED blink on and off every second. Isn't that exciting? Now let's move on to the next step, uploading this program to your Arduino. Now, how do we get this program onto our Arduino board? Well, it's simpler than you might think. Firstly, ensure that your Arduino board is connected to your computer via a USB cable. Your computer should recognize the board as a removable drive. If it doesn't, make sure your cable is in good condition and the board's drivers are correctly installed. Next, let's open our Arduino IDE. This is the workspace where we've written the program that we're about to upload. Take one more look at your code. Make sure it's free of errors and ready to be uploaded. Now, let's move to the top of the IDE. You'll see a button marked Upload. This is our magic button. When pressed, the IDE compiles your code. That is, it translates the programming language into a format that the Arduino board can understand. If the code is compiled successfully without any errors, it's then uploaded to the Arduino board. But how do you know if it's successful? Keep your eyes on the bottom of the IDE. There's a status bar that provides feedback during the upload process. If the upload is successful, the status bar will display the message "Done uploading." This indicates that your code is now running on the Arduino board. However, if you see an error message, don't panic. It just means there's a hiccup that needs to be addressed. It could be a syntax error in your code, a problem with the board connection, or an issue with the board itself. The error message will usually give you a hint about what's going wrong. Remember, uploading a program to an Arduino board is a process of trial and error. It's perfectly normal to encounter a few bumps on the road. The key is to stay patient, keep learning, and keep trying. You've now uploaded your first program to Arduino, but how can you troubleshoot if things don't go as expected? Not everything always goes smoothly in the world of tech, right? It's a truism that rings especially true when you're starting your journey with Arduino. But don't worry, we've got you covered with some common issues you might face and how to troubleshoot them. Let's kick things off with connection issues. You've plugged in your Arduino, but your computer isn't recognizing it. It's a common issue, often due to a faulty USB cable. So, before you start pulling your hair out, try swapping out the cable. If that doesn't work, check your computer's device manager to ensure the drivers for the Arduino are properly installed. Next up, coding errors. These can feel a bit like trying to find a needle in a haystack, especially if you're new to programming. But fear not, the Arduino IDE has a built-in error checking tool. If there's an error in your code, it'll highlight the line that's causing the issue. Then it's just a matter of doing a bit of detective work to figure out what's wrong. Sometimes, though, it's not the code, but the board itself. You might find that your Arduino is behaving erratically or not functioning at all. This could be due to a damaged board. Inspect your Arduino for any visible signs of damage like burnt components or broken connections, and if you find any, it might be time to replace the board. Lastly, let's talk about power issues. If your Arduino isn't turning on, it could be a power supply problem. Check your power source. If you're using a battery, it might be drained. If you're using a power adapter, ensure it's working and delivering the right voltage. Remember, troubleshooting is a part of the learning process. It can be frustrating, but it's also an opportunity to understand your Arduino better. With these troubleshooting tips, you are now well equipped to tackle any issues that come your way. Don't let these common issues discourage you. Keep experimenting, keep exploring, and most importantly, keep having fun with Arduino. Now that you've got the basics, where can you go from here? Well, the beauty of Arduino is that there are countless resources at your disposal, ready to help you expand your knowledge. For starters, online tutorials are a goldmine of information. Websites like Arduino's official site, Instructables, and SparkFun offer detailed, step-by-step guides on a variety of Arduino projects, from beginner to advanced levels. You can learn how to build anything from a simple LED blinker to a complex robotic arm. The best part is, these tutorials are often accompanied by code examples that you can modify and use in your own projects. Next, forums are a fantastic place to connect with other Arduino enthusiasts. Websites such as the Arduino Forum and Stack Overflow have active communities of users who are willing to help troubleshoot problems, discuss new ideas, and share their own projects. Don't be afraid to ask questions. Remember, no question is too simple or too complex. We're all here to learn together. And let's not forget about books. Yes, in this digital age, books are still a valuable resource. Titles like Getting Started with Arduino by Massimo Banzi and Programming Arduino, Getting Started with Sketches by Simon Monk offer in-depth explorations of Arduino's capabilities. These books are not just about programming, they also delve into the hardware aspect of Arduino, giving you a comprehensive understanding of this versatile platform. As you get more comfortable with Arduino, you can start tackling more complex projects. Maybe you want to build a weather station that tracks temperature and humidity. Or perhaps you want to create a home automation system. The sky is the limit. Remember, the more you challenge yourself, the more you learn. The world of Arduino is vast and full of possibilities. It's time for you to explore it on your own. Remember, every expert was once a beginner. So get out there, start experimenting, and most importantly, have fun with it. So there you have it, learning Arduino in just 15 minutes. We've journeyed through the fascinating landscape of Arduino, kicking off with an overview of its hardware components. We've explored the Arduino software, unraveling its features and functionalities that enable us to interact with the hardware. Then we dove into the heart of Arduino, writing your first program. We learned how to create a simple sketch and how to upload it to our Arduino board. Along the way, we tackled some common issues that you might encounter and discussed effective ways to troubleshoot them. Finally, we talked about how to expand your Arduino knowledge. Remember, the journey doesn't stop here. This is just the beginning. Arduino is a vast universe waiting to be explored, and you're now equipped with the basic tools to start your exploration. With this quick start, you're now ready to dive into the exciting world of Arduino. Happy coding!